Hello Codebase family. In this video we will look at how to build machine learning models without writing code. Not that we will not use code, but we will not write that particular code. And I will do a demonstration of this by building a classifier that will classify cats and dogs. So you can see that in my projects folder I have cat and dog classifier, that is the name of the project. And then I have some test IMG and train IMG. So inside the train IMG, for example, what I did was to get images of cats and dogs from the internet, and 15 of each. I used 10 for the training and then 5 for testing. So if I should open any of the folder, you see that these are the images of this is cats. And then I can also open for the dog also. So I just got these pictures from the internet. This is what we use to train the model. And then we can also use it for the prediction also. We use the test image for the prediction also. Inside the test image also there are images for cats and also for dogs. But if you scroll down to the description below, you will see this all these resources and also the source code and every other thing that I will generate here. So how do we go about doing this, right? Not without writing the code ourselves. All you have to do is to go to this website that says it's called Teachable Machine. So the website is teachablemachine.withgoogle.com. And then at this point, what you want to do is to click on Get Started here. It is able to help us build models for all these ones, but what we are interested in for today is the image project. And then we'll choose the standard one. And it tells us that we can add samples using our webcam, or we can choose to upload it. But before I do that, I want to name this one cat. That is the name of the class, because we are only classifying 2 objects, and this one will be dog. So I will choose the upload and then come back to PyCharm. We are using the train images, so what I can do is to open in my Explorer and then first bring the cat. I'll bring all the 10 images for the cat and I'll drop it in here. You see that it will load all the samples in there for us, and then we can scroll down to the next class, which is the dog, and then we can add the dog images also. So I'll select all of it again and then I'll drop it. Oh no. So once we have given it all the classes, the images that we want it to use, then we come to the next step, which is the training of the model. If you want to adjust any of the parameters here, like the epoch, when you put your cursor on the question mark, it will tell you what this one is, and then the batch size and learning rate. But I will leave these ones to default. It will work fine with this, with what we are doing. So after you are okay with all the parameters, you can click on the train model, and then it will be training the model for us. It shouldn't take long, just a few seconds, depending on what you are doing. You can see that it's prompting me to allow camera, and that is after the model has been trained successfully. But if we want to test it with something from our webcam, you have to enable that one before you can use your camera. But that is not what we are doing for today, so I'll close out of it. And then in here too, you see that you can actually test the model to see. So because it was on webcam, that is why it was prompting me to allow Chrome access my camera. But if you can also upload a file here to test it, it will work. But we want to do that in PyCharm, the testing in PyCharm. So what you want to do is to come up here and click on export model. This will open this page for you, and then you see it's export your model and use it in projects. And we are not using TensorFlow.js. We are not doing web apps at the moment. So what we want to do is to come to TensorFlow, and then make sure that the conversion type is Keras, and then this one is Keras. You can also use the OpenCV Keras. It will also work fine. And then at this point, what we want to do is to click on the download my model. You can see that it says convert your model. Okay, it's now converting the model in the cloud for us, and it says it might take a few minutes depending on what you are doing and also the speed of your internet. But what I want us to also take notice of is down here, it says code snippets to use your model. So this code is what we will use, and so we will copy it. As you can see, the model has been converted and then downloaded onto my system. But let me paste the code we copied. So I can create a new file here and call it classifier. And then in here, all I have to do is to paste that code I copied from Teachable Machine. And then before we can use this model, the Keras.h5 model is what we downloaded from the Teachable Machine website. So you have to now extract it, and then it comes in a zip file, so we have to extract it and then use it. This is the file that came from the Teachable Machine, that when we downloaded the model, it will come as a zip. So all you can do is to extract. And then when you extract, this is what you get. You can safely delete this one. You get the Keras underscore model.h5, which is the model that has been trained and saved, and the labels.txt. The labels.txt only contains the labels that we give the classes, but we can't open the models.h5 now. So what we have to do in this code, the only thing we have to do here is to come to where it says replace this with the part of your image. That is where we want to now test our image. So the images for testing is located in test image, and then let's say we want to test with a cat for now. Any random name there, let me see. I can see 2 there. I want to use the 2.png, JPG. And then now I can successfully run the classifier and see. You can see that it's predicted as a cat, of course, because if I open the 2.jpg that we use there, this one, inside cat, you see that it's a cat. It's predicted as a cat with a confidence score of 0.99 or 99%, 99.99% confidence. So let me also change it. I think I have the same 2.jpg in docs also. So let me do docs here and then run the classifier again. This one too was predicted to be a doc with a 99.99% confidence. And of course, if I should open the 2.jpg, you see that it is actually a doc. So it's just that easy to build machine learning models, especially ones that look like this, and those ones too that we also saw that there are other 2 things that we can do on the website apart from image classifiers. But if you have a little time to write just a little code, then we can even make this project a little bit interesting by coming up here and importing matplotlib. We also want to see that we show the image that we are actually testing, and then with the class name and then the confidence on it. So we want to import matplotlib.pyplot as PLT. And then we come to this place where we are testing the image, and then we just write two lines here: plt dot im show. We want to show image, so the image show or im show. And here I want to show the image that we are testing. But we also set the label, the axis also to false. So plt dot axis, we set it to off. And that is what we have to do here. And then we come to where we are actually predicting the score. And then we change these two lines, we modify it a bit so that instead of printing it to the terminal, it will actually display the image. What we want to do is now declare a test variable which is equal to, that is the test that will show on the image. Let it make it an f string and let it be equal to this one. So we just copy this one, paste it in here. Of course, you have to delete this. And then convert this one inside those brackets. No, this bracket is not supposed to be here. Yes. And then we also bring in the confidence score. Maybe you can try putting that one on a new line. So the confidence score. And that one too is this. But you can also choose to convert this one to a percentage or however you want it to look like. And then we can now create the box that will show. So plt.text. And in here we define the position to be 2020. And then we also define what the text will be, which is the text we just created up here. We can pass in a couple of things like the font size, which I want to be equal to 12. We can also pass in, we want to also, in case the image has a white background and the text is white, we cannot see it. So we want to define some colors here. So color, which should be equal to white. And then if this color is white for the image with dark background, we will of course see it, but if it is a white background, we will not see it. So what we want to do is also declare, give it the text itself some background, so that irrespective of the background of the image, it will show. We create a b box, which will be equal to a dictionary of face color, which is the color. So face color of the box, the box that will show the background of the image. The face color should be equal to black. And then now we can also show the image, of course, because you have to do the plt.show before we can show the image. So let's try our classifier one more time with all this modification. Okay, so we can see that it shows the image, of course, that is a dog with a confidence score of this value is quite too long. And you can see that the background too is too dark. If that one is, you also don't like it that way, we will fix it right now. So let's fix this decimal places and then the background too. I think it's too dark. I realize that there's a comma somewhere that is not supposed to be. And then here you can add an alpha, which you, I think, define the opacity. So if I set it to 0.5, that means the black will be 0.5 dark or something like that, if I'm saying it correctly. So what we can do here is to tell Python that we want it to .2f, and that means that it will run it up to the 2 decimal places. So let's test it again and see. Okay, so we can see that now the background is a little transparent, and then the confidence was rounded up to 100% or 1, of course 99.99 or so. So that, my friends, is how we can build a model, a classification model, of course, to be precise, without actually writing all this code ourselves. In fact, this is not the code that built the model. The code for the model, we don't have it here. We only have the model that has been saved. We could have built it ourselves or written the code ourselves and save the model, and then we also get something like this, which will have a .h5 extension. But Teachable Machine does it all for us. So that will be all for this video. Thank you for your time, and be sure to leave all your comments down below and like the video, and consider subscribing also if you are new. And I'll see you another time with another video. Bye for now.